Hi, and welcome to Lesson 1.4, Equations and Inequalities. So to begin with, we need to define an equation. So an equation is formed when an equal sign is placed between two expressions, creating a left and right side of the equation. So it's an equal sign between two expressions. An equation that contains one or more variables is known as an open sentence. So an open sentence has one or more variables. So a few examples of different equations that are open sentences. 4 minus b equals 3, 3x plus 1 equals 7, a plus 3 equals 3 plus a. So keep in mind that an expression can be one term, could be a single operation, or multiple operations. Then, when the variable in a single variable equation is replaced by a number, the resulting statement can be true or false. If the statement is true, the number is a solution of an equation. So when we plug in or substitute a variable and replace it with a number, then we can tell if a statement or equation is true or false. Meaning if both sides are equal, then it would be true. If the two sides are not equal, then it would be false. So if it's true, then we can call that a solution of an equation. Now you want to remember in all these examples to follow the order of operations. And looking at example 1, they just want us to check whether the numbers 2 and 3 are solutions of the equation 3x plus 1 equals 7. So what we're going to do is substitute 2 and then 3 into this equation for x to check if the two sides are equal. So when we're going to check if 2 is a solution, that's over here. Our equation is 3x plus 1 equals 7. The question mark above the equal sign just means we're checking. So we're going to substitute 2 in for x. So we have 3 times 2 plus 1, and then 7 on the other side. 6 plus 1, so 7 equals 7. So the two sides are equal. That is true. So 2 is a solution of that equation. Now checking 3, we have the same equation. Substitute 3 in for x. So 3 times 3 plus 1, 9 plus 1. 10 does not equal 7. So the equal sign with the backslash in it means does not equal. So 10 does not equal 7. So therefore 3 is not a solution. So it's only a solution if the two sides are equal. So now in example 2, we're checking whether the numbers 2, 3, and 4 are solutions to the equation 4x minus 2 equals 10. So I started with the 4, then I'm going to check the 3, and then the 2. And each time we're replacing x with this number. So the first time we have 4 times 4 minus 2. 4 times 4 is 16. So 16 minus 2 is 14. So 14 does not equal 10. So no, that is not a solution of our equation. Looking at 3, substitute the 3 with the x. So 4 times 3 minus 2. Following the order of operations, multiply first. 4 times 3 is 12. 12 minus 2. So we end up with 10 on the left, 10 on the right. They are equal. So yes, 3 would be a solution. And then over here, substituting in a 2 for the x. So 4 times 2 minus 2, we're checking, does that equal 10? 8 minus 2, that's 6. 6 does not equal 10, so no, it is not a solution. And then just a extra little note here, looking at something we'll be doing later this year in algebra. When you find all the solutions of an equation, so not just checking if a number is a solution, but when you find all the solutions, that is called solving the equation. And later in the book, we're going to look at many ways that we can systematically solve equations. So for now, we're just doing simple equation work and checking if a number solves, but later, solving the whole equation, we will find all these solutions. Now, example 3 is a word problem showing how we can set up a simple equation to find out our missing information. So the scenario is that you need to buy ingredients for nachos. In the supermarket, you find that the bag of tortilla chips is $2.99, beans are 99 cents, cheese is $3.99, 2 tomatoes are $1, and olives are $1.49. So in this scenario, we have a $10 bill. About how much more money do we need? So the first thing I did is added up all the total costs that I would be spending. So just added the $2.99, $99, $3.99, $1, and $1.49. That gave me $10.46. Then I could set up a simple equation. I know my cost is $10.46. I had $10, and I'm checking how much more do I need. So then to solve this, I could 1046 minus 10 tells me that x would be 46 cents. Then the other thing that we are looking at based on today's title are inequalities. So we had equations, and then the other type of open sentence that we can have is an inequality. And you might have already had some exposure to inequalities and just not realize the term. Those are symbols such as less than, greater than, less than or equal to, or greater than or equal to. So an inequality is a not equals symbol on its own. It's a less than or equal to, greater than, or greater than or equal to. So an inequality is one of those symbols placed between two expressions. So making sense of these symbols and meanings, the first symbol here, this would read as y is less than 5. The next one would read as x is less than or equal to 3. The little hash mark underneath that less than symbol is the or equal to. The next one would read as z is greater than 10. And our last one, w is greater than or equal to -4. So those are your 4 inequality symbols. And then a solution of an inequality, just like a solution of an equation, but a solution of an inequality is a number that produces a true statement when it's substituted for the variable in the inequality. So we'll look at a few examples of checking if numbers are solutions to inequalities. So in example 4, we're deciding on every one of these if 4 is a solution to the given inequalities. So our first inequality, 2x minus 1 is less than 8. Substitute a 4 in for x. 2 times 4 minus 1 is less than 8. Follow the order of operations. So 2 times 4 is 8. 8 minus 1 is 7. 7 is less than 8. Yes, that's a true statement. So yes, 4 is a solution. In B, x plus 4 is greater than 9. Substitute a 4 in for x. 4 plus 4 is 8. 8 is not greater than 9. So 8 being greater than 9 is not a true statement. So that would be false, meaning no, 4 is not a solution because it does not make sense to say 8 is greater than 9. And then in C, we have x minus 3 is greater than or equal to 1. Substitute the 4 for x. 4 minus 3 is greater than or equal to 1. So our final inequality says 1 is greater than or equal to 1. Well, 1 is not greater than 1, but it is equal to. So this is true. And yes, that means 4 is a solution of that inequality. And then our last example for today is example 5. And it's a word scenario dealing with inequalities. So it's a veterinarian scenario. The vet told you to restrict your cat's caloric intake to no more than 500 calories each day. And that wording of no more than is important. Then it tells us 3 times a day you give your cat a serving of food containing X number of calories. Do the following values of X meet the vet's restriction? So what you want to start with first is writing the expression. And in this case, I know I'm feeding the cat 3 times a day, and I know I'm restricted to no more than 500 calories. So my expression would be 3 multiplied by x, 3 times a day, times the number of calories, is less than or equal to 500, because it can be 500, but it cannot be more than. So that would be less than or equal to. So our expression 3x is less than or equal to 500. Then we are going to substitute in the values given in A and B. So in A, that food is 170 calories. So 3 times 170, we're checking if that is less than or equal to 500. 3 times 170 is 510. 510 is not less than or equal to 500. So no, that 170 calorie food does not meet the vet's restriction. In part B, there's 165 calorie food. So we'll substitute 165 for x. 3 multiplied by 165, we're checking if that's less than or equal to 500. It is 495, so 495 is less than or equal to 500. So yes, that food would meet the vet's restriction. So as you're working on the practice problems for this lesson, please make sure to follow the order of operations when you are checking for your solutions.